So I had a bit of technical difficulty with the last couple of videos I made. My OBS wasn't set up properly. It wasn't centered very well on the screen, so the videos were half cut off. So I'm going to recap a couple of the things that I was talking about in the last couple of videos. And as you may recall, we were talking about this very first picture of a quote-unquote black hole. Now this is, there's more than just a black hole in this picture. And so I wanted to clarify something I said in the last video that someone kind of called me on, and it had to do with this picture here. So in this picture here, I showed you the images on the left, which were cut off in the last video, so hopefully they won't be cut off in this video. So on the left here are two views of the pharoahe cell, the two views of the magnet under the pharoahe cell. So in this view here, we have north-south of the magnet, and in this view we have north-up and south-down, or it might be the other way around, I'm not sure, but they both look like that. And on the right here we have two views of a black hole simulation. So these are two views from a black hole simulation, which I showed in the last video. These are two snapshots from that video, and I wanted to point out how similar these two were to each other in all four views. So the bottom view is like the view we saw, more like this guy. Okay, and this would correspond to, say, one of the poles of the magnet. So I believe these two pictures correspond. And the top two would be the orthogonal view to that. And notice how similar they look. I can't help but notice how similar they look. On the right is black hole, and on the left is magnet. So in the last video I said magnet is a black hole and the black hole is a magnet, and I was kind of loosey-goosey on the language. And since I'm all about proper language, or redoing the language, or being clear on the language, I'm gonna expand a little bit more on that and tell you what I actually meant. So let's have a look here. So when I say black hole, when I talk about a black hole, I'm not just talking about the black part. Okay, I'm not just talking about the black part. When I say black hole, I'm talking about the black part, the event horizon, and this outer part, which is called the photon sphere. Now, the photon sphere is not very well known. Okay, so this is my quasi-black hole. This is my Mandelbrot set as a quasi-black hole. And so basically this is my cartoon, this is my picture of incommensurability and of the three regions of a black hole. You have the black hole, or the black domain, or the dark domain, whatever you want to call it. I call it the domain of convergence, and this is the region where the points on the complex plane contract. Okay, so this is very much like a black hole. It is a black hole, if you want to call them black holes, or we'll just call it the dark domain. And then this outer region is what I correspond to the photon sphere. Now the photon sphere is not very well known. No one knows what a photon sphere is. So let's just have a quick look here at Wikipedia and what they have to say about photon sphere, because this video is going to be basically about the photon sphere. So here they say, and this is really interesting, they say a photon sphere or photon ring. Okay, this wasn't here before this picture was taken, so now they're calling it a photon ring. This is brand new. They weren't calling it that before. So a photon sphere, or now they're calling it a photon ring because it looks like that, is an area or region of space where gravity is so strong that photons are forced to travel in orbits. Okay, the radius of the photon sphere, now called the photon ring, which is also the lower bound for any stable orbit, is a fraction of, or it's 1.5 times, or 3/2 times the Schwarzschild radius. So the photon sphere is part of the anatomy, I'm saying, of the black hole. Now, I can't call it a black hole because people get mad at me. They don't like the word black hole. So I'm going to change the name. I'm going to call this thing, so a black hole event horizon photon sphere, this whole thing, this container, I'm going to call it an ohm particle. Okay? The ohm particle. This is I've been writing a book called The Ohm Particle, and now I have a website I'm working on very slowly and carefully. And basically I'm just putting chapters of my book up there as rough drafts to maybe get some feedback and, to get the ideas out there. So I'm calling them ohm particles. Now, I chose that name because ohm, because there's a Buddhist teaching in here. That's why I'm doing this. I think that, the Mandelbrot set is very Buddha-like, and there's a Buddhist teaching in there. So that's why I chose ohm particle. But ohm particle is sort of a play on the God particle. Okay, so maybe a lot of people have heard of what the God particle is in physics, and so I'm just sort of playing on that name. Plus, it implies wave, because ohm, the sound of ohm was the first sound. So in the beginning was silence, and God said, let there be ohm, a sound. And so a sound is a wave, and so this is wave particle. This could be construed as wave particle duality, but I don't call it that. I call it wave particle unity. So wave particle unity. So if you want to, I don't call it wave particle duality, I call it wave particle unity. And if you want to see what I really mean, you should check out the work of Jeff Yee. He's got a YouTube page called Energy Wave Theory, and basically he models particles as a wave. And so this is really wave particle unity in my eyes. This is really great. And I've also co-authored a few papers with Jeff. And one of the more recent ones, not the most recent one, is Particles of the Universe meets Electric Universe. Now, a lot of people ask me about do I know about the electric universe and do I support it, blah, blah, blah. Well, obviously I do. So all of the things that I'm doing and talking about leads to the electric universe being the correct way of viewing, or a better way. This is the better way of viewing the universe and the cosmos and how it works at all scales. Okay, so I just wanted to bring that up because I've been meaning to point you guys in this direction. I think it's really important. I think you'll find these videos are very well made. They're very well made and easy to watch and easy to understand, and so I highly recommend them. I hope you watch them. Okay, so let's get back to the photon sphere. Okay, in this picture here, I believe what we're seeing out here in the outer donut is the photon sphere, and I think that's what they're saying in this page as well. And so this is the photon sphere. The event horizon would be between the black part and the photon sphere, but really this is a photon sphere. And so when I said a magnet is a black hole and a black hole is a magnet, I meant the dynamics that creates this object and presents itself to us. So don't forget, we're only seeing light or radio waves, which are a form of electromagnetic radiation. We see the radio waves, we convert them to a picture, we reconstruct them into a picture. This is not what the black hole looks like with our eyes, but it is what the black hole looks like when we reconstruct it and present it in a way that we can see. So this whole thing is an ohm particle. I'm going to call this an ohm particle. There's a black hole, an event horizon, and a photon sphere. Okay, so this fits my model, which I am showing right here. So this is my model of an ohm particle. It's got a black hole and a photon sphere and an event horizon, which is just the boundary. It's the domain separator, I call it, between two domains. Counter space and space would be a great generalization for this. So counter space and space. Okay, so the photon sphere. Nobody knows, nobody has heard of it, or hardly anyone has heard of it, and they don't really know what it's for. Well, I believe it's just part of the anatomy of an Ohm particle, that all Ohm particles have a nucleus, let's say, and an outer photon sphere. I like the photon sphere. It's a nice name, but we could come up with a better name for it. But for now, I'm going to call that the photon sphere. And then the event horizon, which is also a great name. It's a domain separator. It separates two domains. So this is what I believe. So when I say a magnet is a black hole and a black hole is a magnet, I mean a magnet is an Ohm particle and a black hole is an Ohm particle. Okay, so this picture here, whatever we're seeing in here, is one of these. It's got the features. Okay, so what is the photon sphere of the magnet? All right, what is the photon sphere of a magnet? Now, I'm going to just show you a snapshot from Ken Wheeler's video. Ken Wheeler's I Told You So video, which he has totally told us so. He told us so. And so just looking at this picture, I can see at this point in the video, he is pointing to the photon sphere, which is this boundary right out here between here. So there's a sort of a little edge here, different color than the outer part here. And this, I believe, is the photon sphere equivalent, the photon sphere equivalent of my Ohm particle, of an Ohm particle. Right? So I have some pictures from that I've been working on. I rebuilt my ferrocell. So maybe I'll just quickly show you a bit of that. I rebuilt my ferrocell. So there it is. I rewired it because I did a really crappy job the first time. So I rewired it. It's much nicer. Okay, there's a little close-up of my wiring. It didn't totally suck. Here's a picture of it with just the lights and no magnet. There's another view of that. There's a picture of it with before I put the cover on, so you can see the wiring and the lights. It just looks kind of cool. Close up of my wiring, my crappy wiring of the power supply. I'll fix that later. So, you know, I did this myself. I'm quite proud of myself. And then I started taking some pictures. So here's a picture of my ferrocell with, and actually this is not my ferrocell. This is Tim Vanderelli's. So this one here, this picture is with his, it's my ferrocell, my light ring, my light box, and his ferrocell. So I was just comparing the one he gave me with the one that I made. And you have 5 magnets. These are cylinder magnets with a little spacer between them. And I just wanted to see what they looked like. You can see there's the, north-south pole, or vice versa. And then there's the view of the cylinder magnet facing up. So this is the North Pole, and you can see this picture. Actually, you can really see the photon sphere. There's a different color in here as out here, and this boundary here is what I'm calling the photon sphere. Okay, you can see it again here. There's a close-up of it. You can really see it nicely, hopefully, in the video. Okay, another view. And now I changed over to my my cell, and there you can see the photon sphere quite nicely. Slightly different colors, but yeah, nice straight on shot. Here you can see it slightly different colors. I was using a different filter on my camera. And here's sort of a side view. This is actually a stack of cylinder magnets. So we're kind of seeing a nice 3D effect here. Come on. And yeah, and a few more views of it. But the point I wanted to make was about the photon sphere. Okay, so let's go to Photoshop now. So I took one of the pictures that clearly showed the photon sphere, and I kind of registered it with the black hole image, and I just wanted to show you. Okay, there's the black hole image, and there's this on top, and I'm just going to slowly fade from the magnet to the black hole. Okay, so there's the black hole. I sized the magnet picture so that the black region matched the size of the black region of the image, the black hole image. And then I wanted to see how closely what I'm calling the photon sphere matches that ring around the black hole. And it's very, very, very similar. You have sort of a bright region here and sort of a more dull region here, and I can see the same thing in my pharoahe image because I had it just slightly on an angle, slightly on an angle facing. So it's a little brighter here, but you kind of see a bit of discoloration down here. So this is the photon sphere, I believe, of the magnet. So when I said a magnet is a black hole and a black hole is a magnet, I really mean a magnet is an ohm particle and a black hole is not just a black hole. There's no such thing as just a black hole, right? There's no such thing as that. There's black hole event horizon photon sphere. It's one thing. There's a black hole event horizon photon sphere. Black hole event horizon photon sphere is one thing. There's no such thing as a photon sphere without a black hole. There's no such thing as an event horizon without these two incommensurate principles. You've got counter space and space. Black hole, photon sphere, dark matter, dark energy, visible matter. Okay, so that's how the universe works. The nucleus of the atom, these are the electron shells, and the event horizon would be where the weak force is, the domain of the weak force. So this ohm particle schematic can be mapped to any scale, including the scale of the magnet. Now, I'm not saying that it looks like that black holes look like that, although I was a little bit hoping that it would look like that. But so the Mandelbrot set is also an ohm particle. So instead of saying, that they're exactly the same, no, they're self-similar. They have properties that are very similar. So this black hole, whatever you want to call this ohm particle, this is how it is presenting itself to us. This is how the light is reaching our eye. This is the picture this is the way the light is presenting itself to us through the ether. Okay? And this, the magnet with the ferrocell, is also the way that light is presenting itself to our eyes. So basically I'm saying whatever dynamics are going on in here, whatever is going on in here that makes the light enter our eyes and create this picture, whatever dynamics is going on here is the same dynamics that's going on here. So a magnet is an ohm particle and it's got the photon sphere there, and a black hole is an ohm particle and it's got a photon sphere here. So that's what I meant when I said a magnet is black hole and black hole is magnet. It's more than that. It really has more to do with my schematic. This is basically a schematic of incommensurability, or at least it's my schematic of incommensurability. You've got the contracting region, you got the expanding region, and you've got the event horizon, which is visible matter. This is phenomenon. This is, this is information, right? So this is a cartoon. This is a schematic of how I see the principle of incommensurability at all scales. So this is a black hole, this is an atom, this is a galaxy, this is a, this is a cell, the nucleus of the cell. This is the chromatin, the DNA. You know, so this can loosely be mapped to every scale in the fractal paradigm, right? So everything has the property of self-similarity, right? Even a human being kind of has this schematic, because we've got, you know, the inner body, and we've got the skin, and we've got, you know, the aura. So this is how I see it. But most importantly, right, the black hole is an Ohm particle, and the magnet is also an Ohm particle, or, you know, what Ken Wheeler might call it, a dielectric object. And, you know, I may be compelled to call it a magnetodielectric object. So every object in nature is a magnetodielectric object with permeability and permittivity, and, you know, governed by the laws of fluid dynamics or flow dynamics. So in the last video, I talked about flow dynamics, I talked about fluid dynamics, and all of these things can be explained with fluid dynamics. Magnetism can be explained with fluid dynamics. Quantum mechanics can be explained with fluid dynamics. So if we did all of these things using the same language, the language of fluid dynamics, which includes turbulence, okay, turbulent black holes, right, turbulent black holes. This is that paper I showed you last time. So black holes can also be related, also are dual. So the language of black holes is dual to the language of fluid dynamics, which this paper talks about. So so I hope this video turned out better than the last two videos where I didn't have things set up very well, and I got to explain many more things today. The photon sphere. The photon sphere is part of the anatomy of an Ohm particle. That's my term for it. I'm going to call it an Ohm particle until someone else comes up with a better name. And I'm going to leave it at that. Thank you very much. Have a good night.